So for anyone watching the recording, hi, my name is Sarah. I am currently a student at Vanderbilt. I do have a lot of experience with Olympiad. I did it all throughout high school, middle school, and stuff. So um, yeah, this is materials science. And a quick disclaimer: I never competed in materials science. So I don't have any tournament experience with this, but I do have a lot of knowledge of like chemistry events and some physics events. So um, yeah, I kind of know how things work a bit with this event, even though I've never competed in it myself. Um, so yeah, this is the roadmap that we have. We're going to go over the rules, some difficult topics, um, some common questions and tips, and then finally we'll have other free resources. And then if we have more people joining later on, we'll have a quick Q&A at the end of this presentation. So we're going to start by going over the rule sheet first. So a brief description of the event. There are 3 parts of this event, which is a lot. Usually there are only 2, but so for this event we have puck testing, which is where you test your build, and I'll get into the puck stuff later. And then we have the written test, and we have the lab activities. So all these sections are weighted differently. We have the written test is worth the most amount of points. According to the rule sheet, it's 50 points max. And then the lab activities is weighted second highest, which is 32 points max. And then after that is the puck testing and the design log. So basically the written test is what you would assume a written test would be, your concept of a written test. It's basically you have questions on a certain like set of topics that they have. And then, yeah, it's pretty self-explanatory. The lab part is they'll basically give you an experiment to do, and they'll give you all the materials for that. You just have to bring your lab materials. They'll give you every other material that you need. And from what I've like found in my research, it's usually like more of a physics-based lab. But yeah, I'll get into that more later as well. And then the puck testing is an interesting component of this event. So basically you'll be creating like a puck, kind of like what I had in the previous slide, that image. It looks a bit like a hockey puck made out of cement. And there are some parameters that you have to meet with this puck. So it has to be 4 centimeters in diameter, and it must be at least 10% cement. And you can make it out of different materials. And basically what you'll do with the puck during the event is you will drop it from a certain height several times until it breaks. So basically you want to have a dry puck. It has to be dry. And you'll start by dropping it from 20 centimeters and then 40, and then you'll drop it from higher and higher heights until it breaks. And then along with the puck, you'll have to make a design log. So basically you just type out in a Word document. In the rule sheet, it has a certain parameters that you need to have. You have to have a cover sheet, a list of the components that you have, that you've made the puck out of, and a data table of at least 10 trials of different amounts of materials. So even though the puck is not worth the puck testing, it's not worth that many points comparatively in this event, it's always good to have a design log, because as long as you bring that to the event and you have all of those like parameters, everything that you need to have in the design log, you'll get like 8 points. So it's always good to just kind of do that to get some free points, even if you don't have time to make a big build. So that's a fun tip there. And then finally, we have a list over here of what to bring to the event. So obviously you want to bring your build if you have one, which is the puck. You have to bring your lab equipment because they usually won't provide that. So if you look at the rule sheet, it should be on page 74. They have kind of a graph, and it'll show you all the equipment that you're allowed to bring, what you really should be bringing. The next thing you should be bringing is an N95 mask, which should be a lot easier to find nowadays than in the past after COVID. But this is basically so that they don't want people like inhaling like cement, like concrete dust during the testing. So that's pretty important. And then you have over here the design log. I kind of went over why you want to bring that, even if you don't really have a very good build. Just bring it anyway. You'll get some points for that, and then I'll probably boost your score. The next thing, pencils and a calculator. Those are very important. They won't be providing these to you during the event. The calculator that you can bring can be a graphing calculator. Basically, any kind of calculator that you could think of, it should be okay to bring. But if you want specific like rules on what you can bring, then I'll have the rule sheet will also talk about the calculator. So it's a class 3 calculator basically, but usually pretty much any calculator should work this event. And then also another important thing that you want to bring, two cheat sheets, basically 2 sheets of paper front and back. You can have one per participant. So if you're competing this event alone, unfortunately, you can't bring 2 cheat sheets. You can only bring one. But on these cheat sheets, you can fit whatever information you want on them, as long as it's just a front and back sheet of paper. And I do recommend with cheat sheets, putting them in like a plastic sleeve, like a protective sleeve, and then taping it at the top, just in case like in your lab you have like you're working with water or like other liquids, so that you don't damage your cheat sheet, so that the ink doesn't smudge, things like that. Make sure you can read it properly during the whole event. So now we're going to go on to difficult topics in this event. So for these difficult topics, mostly kind of go over the written test. So in the written test section, there are 6 categories of topics that they can test you on. And this also goes for the lab as well. The lab can be on any of these 6 topics. So the topics are structure, processing of ceramics and glasses, characterization, mechanical properties, and thermoelectrical properties, and applications of ceramics and glasses. So really, it's a lot of chemistry and some physics as well, mostly pertaining to ceramics and kind of like really like at the atomic level a lot of times. So one of the kind of more difficult topics that we have in this event is the structure, which is the first topic they listed. It's letter A on the rule sheet if you want to look at that. So what they'll be going over in this topic or this category really, or some of the main things that they could test you on are amorphous glasses, crystalline ceramics, and also defects. So amorphous glasses and crystalline, we have a kind of diagram at the bottom of the slide here, kind of showing the difference of amorphous and crystalline glasses. So I personally haven't done enough research on these to give a ton of information about them, but these are definitely I have looked over like a lot of tests from this year, and these are definitely like topics that have shown up a lot in previous tournaments. So these would be good things to study. And I also think that there are a lot of resources online. If you just do a quick Google search, these are definitely things that you could easily learn about online as well. So I think this is a very important topic to kind of go over in your studies. And then obviously defects over here, you should be kind of familiar with imperfections and the structure, how they can influence things like strength, conductivity, and durability. So our next topic that I'm going to go over is characterization. So this one is letter C. I'll see if I'm looking on the rule sheet. So basically, it's a lot of interpretation in this one. So in the first bullet point, it says X-ray diffraction. So this specific one, the specific thing is used for identifying crystalline phases requiring understanding of Ragsdon diffraction patterns. And then so these are basically just methods of interpreting data. So scanning electron microscopy is also another one that's on the rule sheet, which this one provides detailed imaging of surface structure for interpreting microscopy measuring rules. So basically, with this category, there's a lot of interpretation. So you won't be asked to kind of like actually use these machines because they won't be providing these for you, but you will be interpreting a lot of the data from these specific types of like measurements, and you will have to be able to understand these instruments. So you won't be encountering them in the events, but you will have to understand how they work, maybe sometimes the parts of these machines, and definitely a lot of interpreting data. As I've seen a lot of that in some of the recent tests. And the final topic that we're going to go over really briefly here is thermoelectrical properties of ceramics. So that would be a letter E in the rule sheet if you want to look at that. So yeah, so like heat capacity, there's thermal properties like conductivity, expansion, electrical properties, dielectric strength, connectivity, things like this. So if you've done circuit lab in the past, some of this stuff might be a little bit familiar to you. And some of this is also probably familiar to anyone who has taken like AP chemistry or honors chemistry or any chemistry in high school. You'll have a little bit of a background for this. But yeah, basically what this event requires is a little bit higher level knowledge. So I definitely suggest like looking up like college level textbooks. Sometimes you can find free PDFs online. Definitely there are a lot of like resources online that can help you kind of understand this because these are pretty difficult concepts. But if you have a good chemistry foundation or like electricity for like physics, electricity foundation, things like that, or in circuit lab, previous events, things like that, you definitely have a good foundation for this. So, but yeah, this is definitely something that people struggle with recently in this event. So yeah, you'll need to have a lot of knowledge on this and be able to understand the complexity here. Yeah, so next what we're going to go over is, or are common questions that I've seen in exams recently for this event. This event hasn't been, I want to say since 2017, an event, or it hasn't been an event in a while. So that's why we don't have that many people who are in college now who have done this event. So we also don't have a lot of previous questions pertaining to a specific topic, especially because of that. So I have 3 questions I'm going to go over here. And these ones I've taken from some recent tests from like big invitationals that have their tests published online. So I think it was Rickards. That one was one of the first ones. And then let's say Grinnell High School. That might be the other one. But I think they both have their tests for free to see online for this for their invitationals this year. So you can definitely go look at those, look at the questions that they asked because I just chose a few questions from those. But yeah, the first one we're going over, this one's a more math-based kind of problem. So it's using Young's modulus and shear modulus when you're deriving equations. So this specific question requires a lot of, it's actually very simple, but it does require a lot of knowledge about these specific, these separate equations right here. And you need to have a good, strong algebra foundation to be able to figure out how they put together. So basically, I took the numbers out of this equation, but it's asking to calculate Poisson's ratio with this equation. So that's this little mu here, it kind of looks like a V. And then what I basically did was I have these initial equations out here, Young's modulus and shear modulus over here. We had ChatGPT write them out in a easy to visualize format because it'd be very hard if I was just using parentheses. So we have axial stress, axial strain. So E equals axial stress over axial strain, G equals shear stress over shear strain. And then we have Poisson's ratio. And we use these equations, we combine them over here. If you look on the right, and then we have, so we got this one up here. So G equals E over 2 times 1 plus nu. Once you combine these equations. And then the specific question was asking to calculate Poisson's ratio. So you have nu equals E over 2G minus 1. So it requires a lot of algebra knowledge. And you need to be able to kind of move around equations like this. So even if you have just the equations written down in your cheat sheet, you definitely need to be able to manipulate them and kind of use them to solve different questions that they may ask. So these kinds of math questions I've seen are very popular in the specific events written test section. All right, this next one. So this one is just a specific example that I got from one test. So this was mostly going over kind of like stress and strain and stuff like that. So there were in this specific test that I looked at, there was a whole section of the test kind of go over questions that were very similar to this. So yeah, so it says a ceramic undergoes a crack and propagation study and was observed that the crack deflects at the grain boundaries. It's asking what this toughing mechanism is most effective in. So lot of times when you go over previous tests or previous invitationals to try and study, what you can do, what I like to do when I was competing at Science Olympiad, is I would like to go over these answer choices. So we have fine grained ceramics, coarse grained ceramics, single crystals, amorphous ceramics. If there's anything I didn't know, then I would automatically go and look that up and try and put it in my cheat sheet or binder. So I think this specific question and also a lot of other questions that are kind of in a similar format or a similar topic would definitely help you with studying to kind of understand the different specific kind of terms here, and then also like why you might be the correct answer. I personally, I don't, I haven't done this event or haven't studied this event enough to be able to give you a super in-depth answer on why B is the right choice here. But I think definitely it would be a good study method to kind of look at the specific answer choices here and then try and learn these terms because these will definitely show up even if A, C, and D aren't the right answer here. Learning these terms will often help you in other questions in the future as well. All right, and then the last question we're going to go over, it says during the cold working of metals, increase in strength and hardness is primarily due to, it has some answer choices here. Again, same thing with this situation, it doesn't really help you that much to go and search up the specific answer choices because they aren't really terms or like vocabulary terms. But this is definitely a specific question that kind of pops up a lot in this kind of category. I think definitely like mechanical properties, which is letter D on the written test section. If you want to look at the rules, there are tons of questions on this. And I think it's, I don't want to necessarily say easy. It's not an easy topic, but it would be a topic that has a lot of multiple choice questions, and it'd be good to kind of learn this if you're new to the event, so that you can get a lot of those multiple choice points when you're competing in this event in the future. All right, and then so here are some tips that I have, even though I haven't necessarily competed in material science. I have competed in lots of chemistry events. So I've done like chemistry lab, environmental chem, things like that. The one thing I can say, the most important tip that I have is to make sure that you read over the entire rule sheet because it's basically a map of everything that you could possibly need to know for this event. So what I always like to do is I always liked to print out the rule sheet and kind of highlight important parts that I thought I might forget in the future. And then for the sections that have all of the categories of questions that they could ask, I always liked to make sure that I had every single one of those in my binder or cheat sheet, whichever kind of event it is. I oftentimes kind of organize my cheat sheets or binders by the categories that they lay out on the rule sheet, the categories of information, so that I made sure I could have everything in there. The next thing over here, it says, even if you're not confident with your build, please make and bring a design log. I kind of went over this earlier. It's just pretty easy points to get. If you're not confident in your build at all, that's okay. Just bring a design log. You get 8 points for that. The next thing, if you don't have access to a lab for practice, look over previous test lab components and how you approach this specific type of lab. So what I did also notice when I was looking over previous tests for this event is that a lot of the lab components didn't necessarily need a whole bunch of equipment for it. So this event would be very easy to practice in terms of the lab portion at home, and also the written test as well, obviously. But they're usually using just kind of common household materials. I think I looked over 2 tests that had a very common or very similar lab, which was just basically determining the elastic modulus of a rubber band. So just things like rubber bands should be pretty easy to find. So you don't necessarily need to have access to a lab to practice this. And yeah, and then the next thing I have, if you don't have a strong background in chemistry or physics, definitely just borrow a textbook from your school so you can learn some foundational knowledge. Because I know there are a lot of freshmen out there or sophomores who haven't taken chemistry yet, or you don't have a strong enough foundation in it yet. You know, you're only halfway through the school year. So definitely look in your textbooks at the specific areas that are touched on in this event will help you go a long way. and just getting some foundational knowledge. And then once you have that, you can definitely build up on that by exploring online things like that. It doesn't actually have to be from a textbook either. You can go to like places like Khan Academy. They'll have a lot of kind of foundational chemistry stuff that you can study if you don't know where to start. Because I know that a lot of times science Olympiad events will not only touch on touch on topics from school that you learn in school, but also they'll kind of go beyond that. So it's very hard to kind of just do an event based on what you know for the school. So definitely make sure you have a good foundation from if you're in your chemistry and basic physics and things like that, so you can kind of build up on that. You're learning online. And then over here, I have some additional resources. So this is kind of on the PowerPoint. I'm not sure if we're going to post this, but these are hyperlinked. So definitely look through previous tests through the SciOly Wiki Test Exchange. That's a big resource that you can use to find previous tests. And then if you know some specific invitationals, definitely you can always look at invitationals. I think, I'm not sure if you can do it on the wiki, but you can definitely at least do it by state. So kind of look at invitationals from your own state. And then you can check their websites and see if they post their tests. You can even try and email maybe some tournament directors and see if they'll send you their tests after the tournament, so that you can use those to study, because it's probably the most realistic practice that you can get before a tournament. So those are definitely some of the best ways to practice. Another thing I have in here is an MIT course online. It's called Intro to Solid State Chemistry, and it has, I think it has pretty much all of the like lecture recordings and everything. And I think you can get access to a textbook here, so it's a really good resource. Intro to Solid State Chemistry course from MIT. It's just free online. You don't need to pay anything for that. And then down here we have Web-ML online molecular modeling. This is good for kind of practice, kind of like conceptualizing ideas and things like that. It's just an online little website where you can model different molecules and stuff. And then down here we have the North Carolina State SciOly resource page. So they'll have additional resources in that page as well that you can look at, and also some cool YouTube videos that you can use to start learning about some of these topics. All right, so that's the end of the presentation that we have prepared today.